All right, so decimal. I'm sorry, why is that doing decimals? Wrong PowerPoint. Hold on. Somehow that got turned around. It happened. That's not the right chapter either. What the heck? Okay, somebody messed with all this. There we go. That would be the right one. Okay, so common fractions. Yay, back to this. All right, so I'm gonna kind of blow through some of this because I think we all know what a fractions is. Just for Jeopardy purposes, if you ever get put on Jeopardy and they ask you what the top number is, y'all should know that it is the numerator. The middle one is the vinculum. Again, if you ever get on Jeopardy, I don't know when you would, but you know, hey, if you happen to get on Jeopardy one day. Really? Huh. So I said numerator, denominator, let it go. Huh. All right, so we know what proper and improper fractions are. We know what mixed numbers are. Like I said, I'm trying to get through as many of these as I can. Everybody knows how to reduce fractions, right? Y'all have any question about reducing fractions before we move on? I know, a lot of y'all are sitting here rolling your eyes going, we know all this. All right. All right, so there are two different ways to find the lowest common denominator. You just multiply your different denominators and hey, you find your denominator. Not always the lowest one. I think we kind of know how to find the lowest common denominator. For those of you that don't always know the second method that does find the lowest common denominator, you take a problem like that. It's where you have a 9, a 12, and a 4. And you say, okay, so 2 goes into 12 and 4. Bring the 2 out. Go to the next step. You have a 6, 2, and 9. Divide 6 and 2 by 2. Pull the 2 out. Then you come down to the next row where you've got 9, 3, and 1. Your goal is to have all ones at the end. So 9 and 3 come with 3. You have the last 3 left over. And then everything's all ones. So you end up with 3 times 3, which is 9, and 2 times 2, which is 4, which gives you 36. Or you can do what I've always done and say, okay, so where do these numbers actually physically converge? Right? So, I don't know about y'all, I've always sat there and said, okay, we have a 9, a 12, and a 4. Where do 9 and 12 meet? 36. Anything 4 goes into, I'm sorry, anything 12 goes into, 4 is going to get drug along, right? All right, so adding mixed fractions, we've already kind of done. So this is the way that they've generally worked it out. They tell you that you pull the whole numbers, you pull the fractions, lowest common denominator, solve. Okay? That is one of the easiest ways to do that. Why do we always pull the whole numbers? Well, because the whole numbers just get in the way, right? The only reason I would really keep the whole numbers is for subtracting, and that's simply so I can pull the whole number out of the pot if I need to. Okay? I don't know about you, my math teacher always said, if you're going to do this, you should do improper fractions for everything. Subtract it out, and then go back to finding your proper fraction. Why would I take 10 times longer to go around the barn? If I've got a barn, why am I going to walk all the way around it when I could just walk through the doors? I don't know. And then we've kind of gone over subtracting of the fractions. So here's the way that they've got for an example to do it. They've given you 6 4/5 minus 4 1/3. Lowest common denominator is 15 here. Anything you do to the denominator, you've got to do to the numerator, right? That is the biggest thing to remember with fractions. If you decide to start playing around with that denominator, what do you got to do to that numerator? You got to do the same thing, right? If I multiply that denominator by 2, I've got to multiply that numerator by 2. I don't get to leave it behind. So if I multiply 5 times 3 to get 15, and then 3 times 5 to get 15, I do the same thing to their numerators and get my answer for that. 6 minus 4 is 2. Bring them together, you get 2 and 7/15. All right? Any questions on that, guys? All right. So borrowing, we've already kind of gone over this a little bit. The whole purpose of borrowing is just like whenever you're trying to subtract in decimal format. Where do we borrow from in decimal format? The next one in front of it, right? Always borrow to the left. Same thing in fractions, right? We can't borrow from another fraction, we borrow from the whole number. Okay? All right, so here's one where they show you how to do the borrowing as well as find the way to reduce. So they start off with your first problem, which is 4 2/3 and 7/9, which, guys, if you do not know that 3 goes into 9 three times, let me know and I'll show you this. So your lowest common denominator here is 9. Again, whatever you do to your denominator, you do to the numerator. So you end up with 2/3 becoming 6/9. So 4 6/9 minus 1 7/9. And of course, they start into the new problem again. They borrow 1 from the 4 to make it a 3. Add 9/9, which is 1 to your 6/9 to give it 15/9. Separate and subtract. 3 minus 2, 1 is 2. 15 minus 7 is 8. You cannot reduce 8 and 9. So you end up with 2 and 8/9. Quick, easy, done, right? Multiplying. So multiplying is interesting because there's a couple different ways. Nah, I'm just going to leave it at that. Multiplying is easy. You just multiply across. If you have a whole number, that's where you have to do the improper fraction, right? I said I'm trying to kind of rush through this so we can get down to the one that everybody has the biggest problem with, which is division, right? When multiplying mixed fractions, you turn your mixed number into an improper fraction. So you do 5 times 4 is 20, plus 3 is 23. Leave it over the denominators as is, multiply, simplify. Does that make sense? Did I lose anybody? Because the biggest examples of this we're going to do are in the next one. And this is my personal favorite way to do fractions as far as dividing. And that is where you flip and multiply. Why? Well, because it's less aggravating. Anybody remember this particular one? Because the other way, and I'll go ahead and show you what this one is. The other way is a roadmap, and I don't like following that particular roadmap. How many of y'all like to follow that roadmap? It's called the cross-multiply method. Numerator, denominator, numerator, denominator, numerator, denominator. If you mess yourself up, you get it wrong. Yes. Huh? Yes. Like I said, I am recording this, guys, so if y'all want to go back and review it, and I also have these slides out on Blackboard. It's under course content. I'll show that to you here in a minute. So the invert and multiply method. You just flip the second number and multiply. I like that a lot better than trying to remember up, down, up, down, up, down. Just call me crazy. So in this particular case, you switch 3 and a fourth divided by 1 and a fourth to 3 and a fourth times 4 over 1. Speak. So you multiply 3/4 times 4 over 1, which what is 4 over 1? 4. Really easy, right? So you multiply it out, 3 times 4 is 12, 4 times 1 is 4. You end up with 12 over 4. Then you just divide it out, which I don't know why they have to do divide by 2, when you can just divide by 4. 12 divided by 4 is 3, right? 4 divided by 4 is 1. 3 over 1, 3. So I do have to say that this is the cross multiply method. It is not my favorite method because it is way overcomplicates things. How many of y'all's teachers actually made you do this method? All our teachers made us have to do this method. Yeah, I've never had teachers that could agree on, let's do it just this one method. Exactly. Yes, whenever they do the show your math on things, that was always the worst because I always got caught doing the wrong methods. Again, my mind works in very different ways sometimes. All right, so same thing for when you do dividing mixed fractions. You just do it as the improper fractions, split the improper fractions, everything like that. Okay. We'll do a couple of those on the board here in just a few minutes. So using cancellation to simplify, how many of y'all remember to do this one? A couple of y'all, maybe, kind of, sort of. So whenever you're doing cancellation, this just is to make everything easier when you multiply and divide the fractions. Okay? Everybody with me so far? So you take a large fraction and you're just trying to make it simpler so that you don't have to do as much work at the end. Does that make sense? So you always do it across from each other. This is why I always got in trouble with cross multiplying, because I always got it mixed up with this. How many of y'all did that? I always got it mixed up with this, where you have trying to do cancellation. But when you get to the multiplication point here, you take your 5 and your 15 for this particular problem. 5 goes into 15 3 times. You simplify this out to 1 and 5. Very easy cross simple. You're just going across. Then you have 8 and 4. 4 goes into 8 2 times. 4 goes into itself 1 time. You end up with a 1 and 1. So you end up very quickly just by canceling out the number, letting the numbers cancel each other out as 1/2 times 1/3, just 1/6. You take numbers that cannot be simplified and you really very quickly and easily simplify them. that make sense? So you basically take everything and make it a lot quicker. So doing a couple of division problems, I'm going to go ahead and